So in the second example, there is a corporation that plans to build maximum of 11 stores. So maximum of 11 stores in a large city. They will build these stores in one of the three sizes. Okay, so the sizes are three. The first one is a convenience store which will open 24 hours a day. Second type of a store is a standard store, and the specifications of this standard store will be mentioned later on. And the third type of a store is an expanded service store. So this company wants to make these three types of stores. The convenience store requires $4.125 million to build. So this is the amount for the first type of store. It is $4.125 million to build, and it needs 30 employees. Okay, so these are the specification. The first specification for a store is how much dollars it will take to build and how many employees are required to operate. Okay. The standard store, which is the second type of a store, it requires $8.25 million to build. So that's the specification number one. And second specification for this store is that it needs 15 employees to work. Okay, so the second number is 15. And the expanded service store requires $12.375 million to build, and it needs 45 employees to operate. So these two conditions are given for this. The corporation can dedicate $82.5 million to build. So the total amount this company can pay in order to build the store is maximum of $82.5 million, and maximum it can give you 300 employees. So now we know that what are our constraints here, right? On the average, the convenience store nets $1.2 million annually. So the annual revenue from the first type of store is $1.2 million. From the standard store, it is $2 million. And from the extended store, it is $2.6 million annually. So these are the conditions given for us. How many of each should they build to maximize revenue? Okay, so this problem is of revenue maximization. Great for us. Okay, and we should formulate the problem in form of a linear programming model, which we have discussed in class. And how many of each should they build to maximize revenue? Okay, so we have identified all our requirements for this problem. What we'll do is that we'll solve this problem with the help of Excel sheet. So I've selected Excel here, and this is our example number 2. So example 2, step 1, we need to identify decision variables. So decision variables, and what are our decision variables? The type of a store which has been built. So our first type of a store is a convenience store. So we will name it X1. So X1 is convenience store. Okay. The second decision variable is standard store. So we will define our second decision variable, and third decision variable is we need to build the expanded service store. So expanded service store. Okay, so let us place this decision variables in proper order. So these are our decision variables. Okay, we'll just name this here. We will leave one row blank, and in this row we need to identify the values which we need to place, and here we have to do revenue maximization. Fantastic. So our revenue maximization depends on how much these stores earns annually. So we'll place these values 1.2, 2.6 and 2 just below x1 and x2, leaving one row blank. 1.2, 2 and 2.6. So 1.2, 2 and 2.6. So this becomes the value of revenues. Okay, so this thing has been set. Move to step number 2, and step 2 is that we have to identify the optimization function, and our optimization function is we need to maximize revenue, so it is revenue maximization. And we'll identify this later on. Okay. Step 3, we will define all the constraints, and the constraints are defined as C1, C2 and C3 respectively. We have identified that there are 3 constraints. Constraint number 1 is that this company can build maximum of 11 stores under any given circumstances. They are not allowed to build more than 11 stores. So the value of x1 will be x1 plus x2 plus x3 should be less than or equal to 11. So x1 is 1, x2 is 1, x3 is 1. They should be less than or equal to, less than or equal to 11. This is our constraint number 1. Constraint number 2 is regarding the amount that has been required to build these stores. So it is 8.25 for x1, 8.25 for x1, 4.125 for x1, 4.125 for x1, 8.25 for x2, 8.25 for x2, and 12.375 for x3, and the total amount they can pay in order to build these stores should be less than or equal to $82.5 million. So it should be 82.5. This is our constraint number 2. Constraint number 3 is regarding the maximum number of employees. Okay, so they need 30 employees to operate x1. So 30 they need to operate the first type of a store. Second type of a store is maximum they need a 15 employees, so 15 employees. And the third kind of a store requires 45 employees, so 45, but maximum they're allowed to have is 300 employees. So this is our constraint number 3. All set. So our Excel sheet has been set. Now what we need to do is that we will first define sum product here. So sum product for constraint is, first is regarding the number of stores they can open and the blank x1, x2, x3. Make it fixed by pressing F4 and drag it down. The same step we have to do for our revenue maximization sum product. First to identify the revenue they are earning from these stores. Also make it fix. Sorry. Do it again. So 1.2 to 2.6. Fix it, comma, and the values of x1, x2 and x3 respectively. Fix it, close it, press enter. So then you select this 0, go to data tab, select solver. Don't change anything here because our objective is already set. We need revenue maximization, so we have to select max here. Which values we need to change? We need to identify the values of x1 x2 and x3 respectively. And now we have to identify constraints, so we will press button add. Constraint 1 less than or equal to 11, add. Constraint 2 less than or equal to 82.5, add. Constraint 3 less than or equal to 300. Okay, so all three constraints are done. Don't change anything here. Go to select a solving method. We will select simplex LP method. Press button solve. Okay, so everything has been set. We have found a solution. Don't change anything here. Press button OK. So okay, so we have identified the values of x1, x2 and x3, and now we will do our analysis. We will build two type of store 1 as mentioned here, comma 9 types of store 2 and 0 type of store 3 in order to get the maximum revenue of $20.4 million. So this is the analysis part which has been required. Thank you very much.